Hello, this is Max talking about his ScanLine Renderer that is made as part of his coursework for Advanced Mathematics and Graphics. So what a renderer is and how it works and how I built it is all in the documentation. This video serves to show the results and is an elaborate readme. So if you open up the project file and compile it, the project creates an application in the debug, and it also gives you this command that you have to run through your command because the whole renderer is run through the command line. So what I'm now doing is going into the project's debug file and copying the address on my computer and changing the directories in the command terminal so it finds where the renderer is. Now I've built a model in Maya, which you'll see shortly, and I've exported it as a text file, and that's what my renderer reads. So if I take that file from the Maya export, paste it in the debug, then I go back to the command line. This is done automatically by the project. I'm just going to write it in manually. So I'm saying this is the name of my render application, model.txt is the name of the text output from Maya, and output.tga is the name of the output file. This is the Maya model being rendered through ScanLine rendering and essentially ray tracing. I've got two light sources, and that's what gives it those neat contrasting effects. The material is specular, so it takes a lot more time to render than a perfectly diffuse model, which I'll show you in a second. ScanLine isn't perfect, it only handles spherical, circular models, and there are some artifacts as well, but I'll be addressing this over Easter. The second model takes a very small amount of time to render. This is because the material is perfectly diffuse and the light is being shone in an orthogonal. In this example you can see some really nice anti-aliasing, and the algorithm for that was very generously handed to us in Gareth's lecture notes. This config file is a simple parser. The models were all made in OpenGLES2 because I find DirectX a bit of a nightmare to work with. These header files were literally lifted from Andy Thomason's SourceForge files that I worked with a lot in my semester 1 in Japanese Pong. So I give credit to that at each at the top of the headers. The ScanLine header I created, it just sets up all the variables, initializes what we need to use in the CPP. Right, this is going through the meat of it, the ScanLine CPP. To start from the main, I have some error handling because loading the external file caused a lot of headaches. This is the ScanLine rendering part of it. We send out a ray in a particular direction for every pixel on screen, and then we check for an intersection or if the ray is in the shadow of another object. This Blinn algorithm is fairly simple but a nightmare to code, but it does give some really nice reflection on the surface of the Lambert. The TGA header file pretty much does what it says. This is a scene CCP, so this is where I'm loading up the external text file. I have over 20 error handlers in the voice of Navi from Ocarina of Time, just because loading in the text file, there was infinite problems with that. So far I got some nice results, and I'll be working on this over Easter in the form of a ray tracer. And until then, thanks for watching.